the sun may be quietly watering the moon. A new NASA experiment shows that nothing more than solar wind particles and ordinary lunar dust can create freshwater molecules. An insight that could help future Artemis astronauts tap local resources instead of hauling every drop from Earth. Picture a barren gray world with no atmosphere, no flowing rivers, and temperatures that swing hundreds of degrees each day, yet beneath its dusty surface, water is quietly manufactured by sunlight itself. That is startling implication of a new NASA experiment, the first to reproduce in the lab how the charged particles of the solar wind can team up with ordinary lunar soil to forge fresh molecules of water on the moon. The idea isn't new. Since the 1960s, scientists have speculated that protons racing outward from the sun might slam into the moon's regolith, steal electrons, wander through mineral grains, and bond with oxygen to form hydroxyl and water. Spacecraft have repeatedly detected a dip near 3 microns in lunar infrared spectra, an unmistakable signature of those molecules. And that signal waxes and wanes through the lunar day. It peaks in the chilly morning, fades under the midday sun, as some molecules hop away or escape to space, then re-emerges after nightfall. The pattern hints at a constant, active source of hydration, yet every lab attempt to replicate the entire chain of chemistry had been clouded by earthly water contamination. That hurdle fell when researchers at NASA's Goddard Space Flight Center sealed Apollo 17 dust inside an airtight vacuum chamber that held everything: a particle accelerator to supply mock solar wind protons, temperature controls mimicking the moon's day-night extremes, and a spectrometer that monitored the soil without ever cracking open the container. After bombarding the grains with an 80,000-year dose of solar wind equivalent, the spectrometer recorded the same 3-micron fingerprint spacecraft on the real moon. The size and shape of the dip show that both hydroxyl and bona fide water had formed inside the sample. In essence, with nothing more than lunar dirt and hydrogen from the sun, nature had stitched together new water molecules before the scientists' eyes. The result carries immediate weight for NASA's Artemis program, which aims to base astronauts near the moon's south pole, where ancient ice hides in permanent shadow. Solar wind chemistry now appears to be topping up those reservoirs atom by atom, day after day. That subtle trickle means in situ resource utilization systems might harvest not just ancient deposits, but a continually refreshed supply, turning local water into drinking fluid, breathable oxygen, and rocket fuel. The finding also helps explain why meteor showers sometimes trigger fleeting plumes of water. When comet dust punches through the dry upper crust, it can liberate hydrated layers created by the same solar wind process. Beyond practical logistics, the study deepens our view of the moon as a dynamic body. Far from a static relic, its surface hosts a slow but ceaseless exchange among sunlight, dust, and vacuum. Every dawn sets off a microscopic migration of hydrogen. Every dusk locks some of it back into rock. In the grand vacuum of space, the sun is painting invisible brushstrokes of water across the lunar surface, one proton at a time, quietly rewriting what it means for a world to be dry.